Hello and welcome to this video tutorial for Activity 2. Through this puzzle, you will help your undergrad or your middle school students explore some of the mathematics of people and small preferences and how these small preferences can lead to larger effects in society. No mathematical background will really be required for this one. All you have to do is follow some simple rules and be able to do a little bit of arithmetic. Okay, so this puzzle, what you're going to do is you are going to have a little talk with your middle school students about the behaviors you observed in the activity with your mentors or with the co-mentors in the human 8x8 grid version of this activity. If that was done beforehand, if not, then this will be the first time where you get to talk to your students about how these sorts of biases can maybe affect society at large. Like we could ask them about, well, what if we prefer to have at least a third of our neighbors speak the same language as us, or maybe have the same color as us, as in these tokens here have two different colors. Maybe it's the same political beliefs, religious beliefs, a number of different things. Of course, I'm going to leave that up to you to talk to your students about because that is outside of my depth. Okay, so let's talk about the rules and how you can run this. What I suggest is that you, as the mentor, maybe set up one or two of these boards for your students. And so you want to take 4 of the whiteboards, maybe draw some grid lines on them to make an 8x8 grid. So you have about 64 squares to play with. Then you're going to want to get tokens of either 2 colors, or like the 1 color tokens is like one side's one color, the other side's the other color. You're going to want about 25, 26 of each color. You probably want to have the same number of each color, or you can see what happens when you have a different ratio of the colors available to play with. Then you'll want to agree on an intolerance level. And so in this version, each token is only happy if at least 33% of their neighbors are of the same color as that token. You'll want to maybe model a first turn for your students at each of the boards that you have set up, and then ask them, okay, now let's look for other tokens that are unhappy, and we'll move them randomly. And it would be good if you let the students like take the token and move it to a random open space, and then take turns. Like, okay, now that you've taken a turn, let's have so-and-so take a turn and see which we can move. And this way that they get to actually like physically play with the activity, and it's more like a fun game for them. And then it's also an opportunity for you to talk to them about stuff that you read in the teaching manual along the way. Okay, so let's start. If I was the mentor at my table, I would say, okay, well, let's look for a token that's unhappy. This one here has 1, 2, 3, 4, 5 neighbors that are all of the opposite color from this blue token. So this blue token is sad and wants to move. So the blue token moves somewhere else. It doesn't have to be an optimal move. It's random, and so that's okay. So now let's look at this next token. Well, this token here has 3 neighbors, only one of which is the opposite color. So this token's happy, and so it stays. Let's look at this token. It has 1, 2, 3, 4, 5 neighbors, and only 2 of the neighbors are of the different color. So 40% of the neighbors are a different color. That means this token is unhappy, and it also wants to move. So it's going to move somewhere random, maybe here, and continue on like that. Encourage your students to look for those tokens. Any token that's inside of a segregated region, clearly doesn't want to move in this scenario, and so stays there. Maybe you can even ask your students like, oh, after a couple of rounds, what do you think will happen if tokens in segregated regions don't want to move, or in separated regions don't want to move? What's going to happen over time as we keep progressing through the simulation? And hopefully they say, well, if tokens wind up randomly and they don't want to move away from regions where they're segregated, then maybe over time the board will become more segregated. Might be a good observation for a student to have. If they aren't getting there, maybe try to ask them leading questions to try and get them to see this. Okay, well, that's the base game. We recommend that you explore some of the other versions as well. Like, for example, change the intolerance level, reset the board, and then try again, see what happens. Even with moderate intolerance levels, it should, in the limit, approach a segregated region. So there's that. Let's talk about the other version that you're all going to play, at least toward the end. And this is the one where we want to talk about introducing a way to undo the separation of the two colors, or a segregation of the two colors. You might want to set up your board where there are clearly segregated regions. Like, for example, you can see a higher density of red tokens in this square and a higher density of blue tokens in this square here. Things like that. And so you can see that there are segregated regions. Again, as the mentor at that table, maybe your co-mentor be like, oh, so which, you can talk to your co-mentor, say, which token do you think will not be happy? And so the way that this diversity parameter works is I have it at 87.5%. 87.5 is 100% minus 12.5%. So this is requiring that at least 1/8 of the neighbors be of a different color. So what's going to happen is a token like this one would have been happy if it was only trying to satisfy the intolerance quota. But because it also wants to satisfy this diversity quota, it's now unhappy here because look, all of its neighbors are of the same color, so there's no diversity in this neighborhood whatsoever. So this token wants to move out of the neighborhood. It can move here randomly. And now we see that it has 1, 2, 3, 4 neighbors. And 1, 2 of the 4 neighbors are of the same color. So that's 50% of the same color as this token. And at least one of the other tokens is of the opposite color. So this token is now happy having moved there. Okay, there are a number of other options that you'll have for the game changer. You'll want to maybe discuss some potential rules with your middle schoolers. Maybe they have some really good ideas, or maybe you want to go with something like this. Okay, that's it for this video tutorial. I hope you found this helpful. And I hope that you will enjoy leading your middle school students through this activity. That's all for now. Thank you very much. And I will see you on Monday. Bye.